was made for number 87 from your textbook in section 1.3. 87 says, find the limit as delta x goes to 0 of f of x plus delta x minus f of x, all divided by delta x, knowing that f of x is equal to 2 square root of x. So I'm going to go ahead and I'm going to set up my limit structure. Limit delta x goes to 0. I know I'm going to keep this subtraction sign, and I know my delta x is going to stay on the bottom. The next thing I have to plug in is f of x plus delta x. Well, f of x is 2 square root of x, which means that f of x plus delta x will be 2 square root of x plus delta x, because my input just changed from an x to an x plus delta x. So my input changed from an x to an x plus delta x. The next thing then that I have is minus f of x. Well, and now it's all messy, but f of x itself was given to us as 2 square root of x. So I'm here. All right, first method for evaluating a limit is to try direct substitution. So I'm going to say 2 square root of x plus 0 minus 2 square root of x all over 0 goes to 0 over 0. Again, notice the arrow is not an equal sign because we're not equal to something that is indeterminate. But 0 over 0 means I need to keep going. When I see a square root in my quotient, I'm going to go with my gut and say I should be using something with a conjugate. So I'm going to set this up again. 2 square root of x plus delta x minus 2 square root of x all over delta x. And I'm going to multiply by the conjugate of the numerator, because that's the part that has my square roots that I would like to force into a difference of 2 squares. So plus 2 square root of x. What I do on the numerator, I've got to do to the denominator to make sure that I'm not actually altering the value of this expression. All right, so now the whole purpose of this was to force a difference of squares. So if I take first times the first, I end up with 4 x plus delta x. Sorry, the color is not that great. When I do the outside and the inside together, they cancel out because I get a positive version of this product and a negative version of that product. So they will cancel. And then when I do my lasts, I get negative 2 times 2, which is negative 4, and square root of x times square root of x is x. All of this then, I still have the limit as delta x goes to 0 all over. And I'm going to leave this delta x factored out. And the way I like to remember that is I chose the conjugate to help me with my numerator. The reason the conjugate shows up in the denominator is just because of keeping things balanced within math. Okay, but I'm going to leave it just as it is because it's really just inserted there to make things nicer. So across the top, that's a delta x. I'm going to get 4x plus 4 delta x minus 4x all over delta x. And again, choosing to not multiply that in because the conjugate was not there to help me with the denominator. It was there to help me with the numerator. And now canceling happens. So 4x and 4x go away. This is where the magic happens. If I get rid of a delta x and a delta x, that's me getting rid of my 0 over 0. So now, when I try to take this blue limit, I don't know why my pen is struggling so much, but I have 4 over 2 square root of x plus delta x plus 2 square root of x. So when I do direct substitution this time, I get 4 over 2 square root of x plus 2 square root of x, which is really 4 over 4 square root of x, which finally then my limit equals 1 over the square root of x, or as your book says, x to the negative 1/2 as its equivalent. Okay, so that should help with number 87. The next one, or the last one rather, from this section of 1.3 is a true-false question dealing with this absolute value of x over x. And later people asked in section 1.4 about number 17, and I'm going to say you should use this same video for that one also, and I'm going to put that in the title so you know that this also is 1.4 number 17 because it's referring to the same graph. So what I want to set up for you first is that the limit as x goes to 0, the square of absolute value of x over x, when you plug in 0, you get 0 over 0, which means we have to keep going. And with this one, there's not really some obvious factoring or trig or anything to help us. So first I'm going to talk about just the line y equals x. The line y equals x looks like this, has a slope of 1, makes a 45-degree angle at the origin, goes through the origin. It's like our perfect parent identity function, right? X and y are exactly equal. In goes x, out comes y. Well, the next thing I'm going to do then is I'm going to take the absolute value of x. And that means that anything that was negative now gets flipped because it's representing a distance up here to be positive. Okay, so now I have y equals the absolute value of x. And this side of my graph stays as it was. So this whole thing in purple is our absolute value of x graph. Cool. Well, now I have the ability to write the absolute value of x as two separate pieces. One piece that is dotted and one piece that is solid, although this is still going to be solid, right? I'm just using it to show the difference. So this left side of my graph, this first piece, is just a line with the slope of -1 and a y-intercept of 0, and that's true anytime x is less than 0. This positive part over here is still just the line y equals x, and that's anywhere x is greater than 0. And now it doesn't matter if you include the 0 in the top piece or the bottom piece, you just want to include it in one piece. All right, great. Well, Ms. Schwartz, this wasn't talking about anything with the absolute value of x. It was talking about the absolute value of x over x, and you are correct. So I had this function. Well, I'm going to change my absolute value of x over x, which means this has to go over x and this has to go over x. Okay, cool. Still looking for the limit as x goes to 0. Now I still get 0 over 0 and 0 over 0, and this isn't getting any better, but algebraically speaking, negative x divided by x is always going to be -1. And x over x is always going to be +1. So when I go through and evaluate this limit, the limit as x goes to 0 from the left is -1, from the right is 1, and because the limit as x goes to 0 from the left of f of x is not equal to the limit as x goes to 0 from the right of f of x, overall that limit doesn't exist. And if the limit doesn't exist, then it definitely cannot be equal to 1. So false. Number 17 asks you to find just the limit as x goes to 0 from the left. Well, numbers that are coming to the left of 0 are numbers that are less than 0, so you would substitute into this part of the piece, this piece of the function, so you end up with -1. Okay, hopefully that helps with that absolute value graph and understanding how those things are lining up.